On June 23, 2022, Ukrainian radar operators detected a rapidly approaching object. Air defense systems attempted to track the target, but the object performed such sharp maneuvers with G-forces reaching 30 units that no anti-aircraft missile could establish an interception trajectory. Within seconds, a massive explosion destroyed a fortified command post located several hundred kilometers from the launch point. This is how the Russian Iskander operational tactical missile system works. A weapon that makes generals on both sides of the Atlantic nervous and which no one in the world has yet learned to intercept. But to understand how Russia acquired such a formidable weapon, one must go back several decades. In 1975, the Tochka tactical missile system, designated SS-21 Scarab by NATO, entered service with the Soviet Army. For its time, it was an advanced system capable of rapidly arriving at a launch point, aiming, striking, and immediately leaving the area. Later, the modernized Tochka U appeared with an increased range of up to 120 kilometers. But the true pride of Soviet missile engineering was the Oka operational tactical system, developed by the Kolomna Machine Building Design Bureau under the leadership of legendary chief designer Sergei Pavlovich Nepobadymy. The Oka could traverse off-road terrain and water obstacles, striking targets at a distance of up to 400 kilometers, and became the first missile system in history where the task of overcoming missile defenses was solved with a probability close to 1. Then, in 1987, an event occurred that changed everything. The Soviet Union and the United States signed the Intermediate Range Nuclear Forces Treaty. This agreement covered missiles with ranges from 500 to 5,500 kilometers. The Oka did not formally fall under these restrictions, as its range was only 400 kilometers. However, the Americans insisted on classifying missiles not only by flight range, but also by mass and dimensions. The Soviet side agreed to include the Oka in the list of weapons to be destroyed. For the creators of the complex, this was a true tragedy, as they lost the result of many years of work. Simultaneously, work on the promising Oka-U and Volga complexes was halted, leaving the country practically without operational tactical missile weapons. Nepobadymy did not accept this blow. He wrote letters to the highest authorities, proving that the destruction of the Oka was a serious mistake, and convinced the leadership of the need to create a new system that would not fall under the treaty. He personally appealed to Mikhail Gorbachev to begin development, and the General Secretary agreed. On December 21, 1988, a joint resolution was issued by the Central Committee of the Communist Party and the Council of Ministers of the Soviet Union to begin experimental design work on a new operational tactical system under the code name Equality. Nepobadymy was appointed general designer of the Design Bureau and in 1989 created the first conceptual design of the future Iskander. However, in that same year, Nepobadymy left his post, and further work on the complex was led by the talented designer Oleg Ivanovich Mamaliga, who had undergone a brilliant school of training by participating in the development of both the Tochka and the Oka itself. It was Mamaliga who had to carry the project through its toughest years. The collapse of the Soviet Union and the economic crisis of the 90s nearly buried the development. Funding practically ceased. There were only enough funds for a few missile launches per year. The leadership of the Design Bureau was forced to take a bank loan to continue working, but the Kolomna engineers did not give up. The first launch of the prototype took place on February 18, 1993, at the Kapustin Yar test range. In August 1999, the complex was first shown to the public at the MAX International Aviation and Space Salon in Zhukovsky, near Moscow. Western military attachés who saw the declared characteristics of the new Russian weapon were shocked, and Western intelligence agencies immediately began gathering any available information about it. In 2006, the Russian army officially adopted the Iskander M system, and from that moment, a completely new stage in the history of domestic missile weapons began. But the system itself is far more than just a missile. It is an entire column of combat and support vehicles, each performing a unique task. Only together do they turn into a deadly mechanism capable of destroying almost any enemy target in minutes. The heart of the complex is the 9P781 self-propelled launcher. It is built on a chassis from the Minsk Wheel Tractor Plant, the MZKT7930, with an 8x8 wheel configuration, providing it with incredible mobility on dirt roads and cross-country terrain. This massive machine carries 2 missiles at once. Each can be equipped with its own warhead and directed at a separate target. The launcher crew consists of only 3 people. What is truly impressive is that the crew does not need to leave the cabin to prepare and execute a launch. All operations are performed from the inside, which is critical in real combat conditions where every second outside of cover can cost a life. The maximum highway speed reaches 70 kilometers per hour, and the cruising range is 1,000 kilometers, allowing the launcher to be quickly moved over vast distances under its own power. Most strikingly, the interval between launching the first and second missiles is no more than 1 minute. This means that in 60 seconds, the crew can send 2 projectiles of monstrous destructive power to 2 different targets. However, 2 missiles on the launcher are only the first salvo. For rapid reloading, the complex includes a transport loading vehicle mounted on the exact same chassis. It carries 2 more missiles and is equipped with a jib crane for reloading in field conditions. The crew of the transport loading vehicle consists of 2 people, and this machine weighs about 40 tons. The reload time for 1 missile takes about 16 minutes. Thus, just half an hour after the first salvo, the launcher is fully battle-ready again and capable of striking a second blow. It is important to note that despite the high mobility of the chassis, neither the launcher nor the transport loading vehicle can move through swampy terrain, where they would simply get stuck due to their immense mass. The brain center of the entire complex is the 9S552 Command and Staff Vehicle. Fire control and communication with other units are conducted from it. The crew consists of 4 people. It is equipped with a powerful R168-100K Aqueduct radio station with 16 communication channels. The radio range on the move is 50 kilometers, and when stationary with a full antenna deployed, it reaches 350 kilometers. The vehicle can operate continuously for up to 48 hours, providing round-the-clock combat management. A separate role is assigned to the 9S920 Information Preparation Post. This is where exact target coordinates are determined for strikes. Data is prepared for the missile's optical homing head, and then this information is transmitted directly to the launcher. The crew also consists of 4 people, and determining target coordinates takes from 30 to 120 seconds depending on task complexity. The time to issue target designation to the launcher is only 60 seconds. Data about the target comes from various sources, including satellites, unmanned aerial vehicles, or other reconnaissance channels, making the complex extremely flexible in obtaining information about the enemy. In addition to combat vehicles, the column includes the 9T248 life support vehicle, where the crew can rest and eat during long marches, as well as a maintenance and technical service vehicle designed for inspection work with the missiles. Its crew consists of 2 people, and checking 1 missile takes 18 minutes. When this entire column moves along a road, it is impossible to miss. An impressive line of heavy multi-axle vehicles stretches for hundreds of meters. But it is precisely this structure that makes the Iskander a fully autonomous complex, capable of operating independently far from supply bases, which is a colossal advantage in modern warfare where mobility and independence from infrastructure decide everything. Now let us talk about what makes the Iskander a truly unique weapon and distinguishes it from all existing operational tactical missile systems on the planet. We are talking about the 9M723 missile used in the Iskander M modification and the principles that have made it a true nightmare for any air defense. The launch weight of the missile is 3.8 tons, and the warhead mass is about 480 kilograms. Structurally, it is divided into two main sections. The rear cylindrical part houses a solid fuel engine with a single nozzle and a fuel compartment providing acceleration to colossal speeds. The front conical part with a fairing contains the combat load, control block, fin actuators, decoys, and the optical homing head. The missile is single-stage and is controlled throughout the entire flight by two types of rudders, aerodynamic and gas dynamic, allowing it to maintain maneuverability both in dense layers of the atmosphere and at high altitudes where the air is very thin. The main feature that puts the Iskander in a completely separate category is its flight trajectory. Unlike conventional ballistic missiles that fly in a predictable parabola, Iskander missiles move along a so-called aeroballistic trajectory. What does this mean in practice? After launch, the missile gains an altitude of approximately 50 kilometers. This segment indeed resembles a classic ballistic curve with a climb phase and a peak point. However, something completely different happens next. On the descent segment, the trajectory is stretched as much as possible due to the aerodynamic lift generated by the missile body at high speeds. The result is a hybrid of ballistic and aerodynamic flight. The ballistic part of the trajectory provides great range and the ability to use decoys in the thin atmosphere, while the atmospheric part ensures continuous maneuvering that makes the flight absolutely unpredictable for enemy detection systems. After completing the active acceleration phase, the missile reaches a speed of about 2,000 meters per second. At the edge of the atmosphere at the end of the descent phase, the speed increases to 2,600 meters per second, and near the target, it is about 800 meters per second. Throughout this trajectory, the missile continuously performs intensive maneuvers. Immediately after launch and directly upon approaching the target, maneuvering G-forces reach 20 to 30 units. To intercept such an object, an anti-aircraft interceptor missile must withstand G-forces at least 2 to 3 times higher, meaning from 60 to 90 units. No such interceptors exist today. Additionally, in the exo-atmospheric segment of the flight, the Iskander can eject decoys that force enemy radars to dissipate attention and waste anti-aircraft missiles in vain, further reducing the chances of a successful interception. The guidance system deserves a separate discussion. The missile is equipped with an inertial measurement unit that provides navigation throughout the flight. But true surgical precision is provided by the optical homing head. Its operation principle is based on image comparison. Before launch, a photograph of the terrain around the target and the target itself, obtained in advance from a satellite or drone, is loaded into the control block memory. Upon approaching the strike area, the optical head begins scanning the Earth's surface and continuously compares what it sees with the loaded reference image. The control block calculates the degree of match between the two images in real time and corrects the course. The system accounts for the fact that the real image and the reference photo are taken at different angles and from different distances, so the algorithm constantly recalculates perspective distortions. According to declared data, the circular error probable is only 7 meters, although some sources indicate a value of up to 30 meters. Even so, the accuracy remains outstanding for a missile of this class. Crucially, existing electronic warfare tools are absolutely powerless against the optical homing head. All suppression systems operate in the radio frequency spectrum. They can jam radar and satellite signals, but the optical guidance system uses neither radar nor satellite navigation in the final segment of the flight. It orients itself exclusively by visual image, and light cannot be jammed. This makes the Iskander practically immune to the electronic countermeasures that form the basis of modern defense against missile strikes. The missile simply does not hear interference because it sees with eyes rather than listening to the airwaves. The arsenal of warheads that can be fitted to the Iskander is another story. It is the variety of combat loads that turns this complex into a universal weapon capable of solving almost any task on the battlefield. Officially, At least 7 to 8 types of warheads are mentioned, although Russia tries to keep the actual number a strict secret. The most formidable, of course, is the nuclear warhead with a yield of up to 50 kilotons. One such charge is enough to completely destroy a large military base or industrial facility. But nuclear weapons are a final argument. For everyday combat tasks, a whole set of conventional warheads is provided. The cluster warhead contains 54 fragmentation submunitions with non-contact fusing, each triggering at an altitude of about 10 meters above the ground. Detonation is carried out by a remote fuse using a laser rangefinder and radio altimeter. This means that when the cluster opens over enemy positions, dozens of deadly elements cover a huge area, leaving no chance for personnel or light armored vehicles. To destroy command centers located in reinforced concrete bunkers, a penetrating high-explosive warhead is used, capable of piercing a thick ceiling and detonating inside the fortified structure. A high-explosive incendiary warhead is designed to strike ammunition and fuel depots, where the fire following the hit completes what the explosion itself did not. Another cluster modification carries shaped charge fragmentation elements capable of piercing the roof armor of armored vehicles up to 20 millimeters thick, making it an ideal tool against tank columns and armored vehicles which are practically defenseless against a top-down strike. The fuel-air explosive cluster warhead creates a cloud of aerosol mixture that, when detonated, generates a massive shockwave, destroying personnel and equipment within urban areas and shelters. For remote mining, there is a cluster warhead filled with PFM-1 Lepostock mines, allowing a vast area of territory to be instantly turned into an impassable minefield without a single sapper on the ground. Moreover, each of the 2 missiles on the launcher can carry its own type of warhead. This means that one salvo can simultaneously solve 2 completely different tactical tasks. For example, the first missile can destroy a command bunker with a penetrating charge, and the second can shower cluster elements on the infantry positions protecting that bunker. Now about the cruise missiles used in the Iskander K modification. The first was the 9M728 missile, also known as the R500, with an official range of up to 500 kilometers. This is a subsonic cruise missile with a flight speed of approximately 260 meters per second. Its main advantage is the ability to fly at ultra-low altitudes, literally a few dozen meters above the ground, following the terrain. At such an altitude, enemy radars are physically unable to detect it in advance because it hides behind terrain features, hills, and forests. When it finally appears on screens, air defense crews have practically no time to react. The optical homing head uses the same image comparison principles as the ballistic version, ensuring high precision. However, a major international scandal erupted over the next cruise missile, the 9M729, which is a modernized version of the R500. The United States concluded that this missile was a land-based version of the Kaliber family naval cruise missile, which repeatedly demonstrated impressive range during strikes from the Caspian Sea against targets in Syria. The Americans were absolutely certain that the real flight range of the 9M729 manifoldly exceeded the declared 500 kilometers and could reach 2,000 or even 2,500 kilometers. Accusations of treaty violations began as early as 2014, and in 2019, Washington finally withdrew from the 1987 Soviet-American Treaty on Intermediate Range and Shorter Range Missiles. Russia followed suit and left the treaty. Moscow rejected all accusations, insisting that the missile's characteristics matched the declared ones, and even invited foreign military attachés to a special briefing where some parameters of the 9M729 were revealed for the first time. However, representatives of the United States and their key allies pointedly did not attend the briefing, making it clear that their position was final and not subject to discussion. In addition to the main modifications for the Russian army, there is an export version of the complex designated Iskander E. It differs from its older sibling by significantly reduced characteristics. Instead of 2 missiles on the launcher, only one is placed. The maximum flight range is reduced to 280 kilometers due to a smaller fuel tank. The guidance system is simplified to an inertial one without an optical homing head, giving a circular error probable of about 70 meters instead of 7. It might seem like a significantly weakened version, but even in this form, the Iskander E remains a formidable weapon, surpassing most tactical missile systems on the world market. Armenia became the first buyer of the export modification. One of the most intriguing stories surrounding the Iskander is connected to this deal. During the conflict in Nagorno-Karabakh, Armenia used its Iskanders in combat conditions. But after the strikes, something strange happened. Missile fragments were found far beyond 280 kilometers from the supposed launch points. Furthermore, markings for the Iskander M, rather than the Iskander E, were found on the recovered fragments. The Western press immediately picked up this story and put forward the version that Russia had secretly sold Armenia the full combat modification of the complex rather than the export one. Russian representatives categorically denied such accusations. However, journalists from Western publications went even further, suggesting that someone might have smuggled the Iskander M into Armenia, bypassing official channels. Based on this, calls were made for an investigation within the Russian army to find the culprits, as Western analysts claimed the illegal acquisition of such a strategic weapon represented a serious threat not only to regional security, but to the whole world. However, even in the West, few truly believed the smuggling version, and the story remained a mystery to which no side has given a final answer. Another loud scandal broke out over the components from which the Iskander is manufactured. American specialists found that the 9M723 and 9M728 missiles have used gyroscopes and accelerometers from the American company Analog Devices since at least 2009. These high-precision components, critical for the inertial navigation system, continued to be supplied until 2017 and, according to available data, were used in missiles launched in 2022. For Washington, this was an extremely unpleasant discovery. It turned out that American technologies were directly used in one of the most dangerous types of Russian weaponry. After the introduction of large-scale sanctions, Western analysts were quick to state that without access to these components, Russia would not be able to produce new Iskanders. However, the Russian defense industry has repeatedly proven its ability to find alternative solutions and replace imported components with domestic analogs. So such forecasts may well have turned out to be hasty. A separate subject of debate in the West was the cost of the missiles. According to Forbes magazine, 9M723 or R500 missile costs approximately $3 million, and some sources cited even higher figures. This caused bewilderment among a number of American experts. One Iskander missile costs practically 2 or even 3 times more than an American Tomahawk. They questioned why it cost so much when the Tomahawk allegedly surpassed the Iskander not only on paper, but in practice. However, such comparisons appear not entirely correct, since the Iskander and Tomahawk solve fundamentally different tasks and belong to completely different classes of weaponry. The Tomahawk is a subsonic cruise missile for long-range strikes, while the Iskander ballistic missile flies many times faster, actively maneuvers, and is practically impossible to intercept, which in itself justifies the higher cost. As of 2022, the Russian army had about 150 Iskander launchers in service, and each carried 2 missiles ready for immediate launch. That is 300 missiles in the first salvo, capable of falling on enemy targets in minutes. Each is equipped with its own warhead and flies along an individual trajectory. No country in the world today possesses an air defense system capable of guaranteed reflection of a strike of such power and density. That is why the Iskander remains one of Russia's main trump cards in any potential conflict. A weapon that forces everyone who considers a confrontation with the Russian army to reckon with it.